So there is this formula when we look at evaluating sine inverse and cosine inverse of functions, and where does it come from? Of a negative angle, right? So if I say sine inverse minus x, we write it as minus sine inverse of x. And if I say cos inverse minus x, we write it as pi minus cos inverse of x. So why do we do this? We there are many proofs to it. You can even ask AI, but a good way to visualize this is using graph. So if I take the sine graph at principal domain, okay, and let's find the value for 1 by 2 and minus 1 by 2. So sine what is 1 by 2? Sine 30, right? So this is 1 by 2 and pi by 6, right, if I'm not wrong, and this is minus 1 by 2. Now if this is 0 and this distance is pi by 6, and both of these values are the same, graph looks same, and this distance will be minus pi by 6, right? So if I put in 1 by 2, if you look at the inverse, or you take the graph and you tilt it like this, but if you look at the inverse, when I put in my 1 by 2, I get pi by 6, and I put in minus 1 by 2, I get minus pi by 6. So when I put in 1 by 2, I get pi by 6, and I put in 1 by 2, I get pi by 6, and I put in minus 1 by 2, I get minus pi by 6, right? Now let's look for cos. Now let's draw the graph of cos at the principal domain. You should know what principal domain is. And let's see the value for 1 by 2. So okay, 1 by 2 is here. Cos what is 1 by 2? So cos 60 is 1 by 2, and 60 is pi by 3. So don't mind the accuracy of the graph. Okay, pi by 3. So let's look at minus 1 by 2, right? So we cannot go backwards now. Like here we went backwards because the principal domain allowed us to, but here it only varies from 0 to pi, so we can only go forwards, right? Now try to visualize. This is my graph, and at 60 degrees here I got if I form a triangle, I got a cos value of 1 by 2, and now I need to get this minus 1 by 2 by applying the rules. I can see our sine is positive here, this is 0, this is pi, so my angles can range from here to here. So to get a negative answer, I must look at the second quadrant, right? So some 60 degree here, right? Some 60 degree here in the second quadrant. That means this is 120 degrees. This, and the real angle is 120 degrees. And the triangle so formed is a triangle with theta equals 60 degrees, right? So its cos will be minus 1 by 2. It's kind of basic trigonometry, you should know this. So at theta, cos 120 gives us minus 1 by 2. Now that means this is some pi by 3. So the amazing thing here is that cos 60 is 1 by 2, cos 120 is minus 1 by 2, and 120 plus 60 is 180. That means these are supplementary angles. So now look at this equation. When I put 1 by 2, I get 60, right? This value gives me 60 degrees. Now as soon as I put minus 1 by 2, I get 120 degrees, right? Now what is cos inverse of 1 by 2? 60. This is 60. And what is pi? 180. So 180 minus 60 is 120, and that's our value. So this is the reasoning behind negative angles in inverse trigonometric functions. So the same logic is applied to all kinds of graphs, right? All kind of functions. So easy trick to remember this is sine inverse x. Then we have 1 upon sine is cosec inverse x. Sine upon cos, or tan inverse minus x. So wherever sine is dominant, sine 1 upon sine upon cos, we always get a minus sine inverse, minus cosec inverse, minus tan inverse. And whenever cos is dominant, so cos inverse pi minus whatever pi minus cos inverse x, and then cosec inverse minus x equal pi minus, and likewise cot inverse, where cos is dominant, we get pi minus cot inverse x.